Alright, so welcome everybody. So today's video is a bit different. Today I figured I might show you how we can set up your Arduino IDE so we can start writing programs for our microcontrollers. So I want to preface this that I'll be using the VMOS D1, which is a Arduino compatible Wi-Fi board based on the ESP-8266 microcontroller, and basically what it's used for, it's for example Wi-Fi attacks and such, but I want to show you just some basic programs with this. So if you go to the first link in the description, you'll get to this site, which is the VMOS Electronics website, and when you go down you see some tutorials here, and here are some important things. First off, the schematics, and second, the driver. So the schematics is what I'll be referring to, so it will be linked in pretty much every video's description that I'll be making about this board in particular. And here are the drivers. Now I have downloaded this zip file, which you can see right here. This is the zip file, and basically what you do, you double click it, you then double click the setup.exe, click allow, and you click install. I have it installed already, so I don't have to do it. And once that's installed, if you connect it, so you can see I have my micro USB cable right here. I have to turn it around, so you can see here is the micro USB port where I'll be connecting it to, and I just, like, my hands would stop shaking. If I connect it, you can see some lights going up, and on the screen you should see this thing, which is our microcontroller. So it's recognized by the OS, which is great. On the Windows, if you want to check if it's recognized, just go to Start, My Computer, Manage, and then Device Manager, and it should be on the ports, and you should see it. The important thing is the port right here. I'll be referring to this later. So alright, so the next thing we'll be doing is installing the Arduino IDE, which you can get from the next link in the description, or just by searching Arduino IDE. And if you scroll down, you should see download the Arduino IDE, and you should pick the Windows installer for Windows XP and up, and then you just click just download, and we'll start downloading. Now once it's downloaded, you're going to have this thing. Now we're gonna like double click, run it, and install it. I have already installed it, so once you're finished, you just go to your start, and you should see it right here, the Arduino part. So you click it. Again, that's after it's installed, so we can just pause and continue on along later. I'll explain this later, just let me finish this. So once you've got that, the next thing you need to do is you need to go into the installing of the board via the boards manager. So to do that, we need to copy this, which is a link. So once we copy that, we need to go over here to File, and here we should see Preferences, and here additional boards manager URLs, and you just paste that in here and then click OK. The next thing you need to do is you go to Tools, go to Board, find the boards manager, and then type in 8266, search, and you should see this thing, the ESP-8266 by the community. Pick the latest version and click install. I'll come back once this is finished. Alright, so now that we have managed to successfully install our packages, we can just close this out. And next we go to Tools, go to Part and change it to COM4, again referring to what we saw over here. And then go into Board. And we need to find our where is it? Oh, here it is, vMOS D1R1, which should be it if you look at the, oh, we have R2, but it shouldn't matter as much, I hope. You can see it by looking at the back, it's written over there. So we'll pick the vMOS D1R1, we'll wait for it to initialize everything, and next let's try uploading the code and let's see what it does. So it's compiling the sketch. I'm going to explain later what it does. I just want to see if it works. It's still compiling, so just be patient. Okay, it's connecting. It's writing it. As you can see, we have blinking going on. And there we go, it's blinking. You should be able to see it blinking. Yes, you are. So let me actually go ahead and explain what this does. So here at the beginning, I can actually zoom in. So here in the beginning, define LED2. What it does, it tells it like, hey, I need to be able to use the built-in LED. So we pick LED2, and then we pick LED14, which can be then replaced with the D5 later if you have the D5 version of this. Next, here's the setup. What the setup function does, it basically does like, hey, I want you to prepare this for me. So what we did is we told the LED to be set as an output. What this means is like, hey, I am doing something, show it to the user. So what it does, it takes everything that's going on over here and sets it as output, which we can see in the form of the LED blinking. Now here is the fun part, the void loop. This is where the magic is happening. So the digital wire is what we've set up as a pin mode, so it treats it as a wire. That's why it's called the digital wire. And we say like, hey, pick the LED, which we've defined in the beginning of the file, and set it to high. Basically increase the voltage level to the high state, to the highest possible state that it can take, and let it blinking there for 1 second. Then do the same thing but set it to low and set the delay to 1 second again. Basically each second it's gonna turn on for 1 second and turn off for 1 second. Now we can make this go extremely quickly. Let's make it twice as fast. Let's upload it, and it should start blinking really rapidly, hopefully. Oh, it says permissions error, so let's have a look. Yeah, it did not like that. Yeah, it did not like that at all. So packages, hardware, I think yeah, we are still on the control port, so I didn't like the change. So let's keep it at 1 second instead. What we can do, however, is set this to 5 seconds to be turned on for 5 seconds. Let's try that instead. This shouldn't cause trouble. Oh no, what's wrong now? Could not open port 4. What? Why? Okay, interesting. So it can't open port 4. So it could have worked, but I think we need to disconnect it first. So let's save this sketch file and disconnect our microcontroller. Connect it back up. Make sure that the address stayed the same, which it did. And let's try uploading it. Okay, it's connecting, and now it's writing, so we need to disconnect and then reconnect again. So it should start blinking really rapidly once it's finished. Okay, as you can see, it's blinking a lot faster now than it used to. So let's change this to a bit more of a crazy value. Let's make it even faster. Now I think we need to disconnect it now in order to do that. Yes, we do. So we will disconnect, reconnect it. It's not recommended, but it works. And let's try this again. And it should start blinking extremely rapidly, hopefully. It did not. What's wrong? Okay, it's not working at all, so I guess we need to disconnect it, wait for a little while for it to clear itself, and then connect it back up again. Okay, so I've connected the board again to my computer. You should be able to see it blinking over there. And let's try this again. So yeah, it's uploading itself now, as you can see, based over here, and also by the more blinking. And you can see it blinking much faster now. So you need to wait for a little while before connecting it again. But it's blinking much faster now than it used to. So what else can we do? We can actually, I believe, do this. Whoops, did not realize that I had it there. Okay, that's not how it works. I thought I knew how it works, but no, it doesn't. Let's move this again. But yeah, that's pretty much our first program that we wrote. So I hope you guys enjoyed this video. It's a bit of a rushed one, but hey, it works. Hope you guys learned something, and I'll see you guys in the next one. See ya!